Dollar store power banks. Worth the $4 or complete crap? Find out today on Mikey's Lab. Hi, and welcome back to the lab. On this channel we do a lot of DIY, we do a lot of science, we do a lot of making, and most recently we started doing some teardowns. In this particular video, we're going to take a minute and we're going to look at something I picked up from the dollar store. Now, unlike Big Clive, I don't get to call it an awesome name like Poundland, which seems like flagrant false advertising to me, but dollar store power bank. If we take a look at the packaging here, by going to the bench camera for a moment, you can see that it says that mobile devices are up to 100% charge, right, which I guess depends on how big the battery in your mobile device is, and that it has a standby time. Now this concerns me. If it has a standby time, does that mean that the battery management circuit inside of this is actually drawing current? Because if so, it may damage the battery if this is not used in a fast enough period of time. So that's something we're going to have to take a look at when we rip this apart. We're going to hook the battery management side up to our lab bench power supply, and we're going to see if it's drawing current while doing nothing. We're also going to rip the battery out of here, because I believe this says, does it state how big the battery apparently is? Yeah, it says that it's an 1800 milliamp hour battery. We're going to find out. We're going to discharge the battery to the lowest safe value. Then we're going to use my LiPo charger, which gives me a measurement of how much current it has put into a battery, to charge the battery back up to the 4.2 volts. And we'll see how much current went in, and we'll see if that number is true. So first off, let's go into the package here. I'm not going to be gentle. I don't even need this anymore. Alright. Okay, so we have the power bank. This one happens to be all white. Not much to it. You have your two USB ports up here. Alright, so you have the one for charging other devices and the one for charging the power bank. Little thing, if you wanted to put this onto your keychain and wreck the ignition in your car because it's way too heavy, don't do that. We have a little USB cable meant for charging. Those are always handy. I got 10,000 of them. I don't think we need that. We're going to get rid of that. Alright. So, I think we've been nice for long enough. So, let's rip this thing apart and figure out what's inside of it. And we're just going to go grab one of my tools over here. That was easier than I thought it would be. It's almost like they don't mind me getting in here. That's a mistake. Alright, so we've got some goop here designed to keep everything in place. Alright, so I'm just going to take my spatula right here, cut through that, cut through that. Let's see if I can just pop this out now. I can. Alrighty, so we have our battery right there. I'm willing to bet that there is some protection circuit on top of here, because this looks a little big for 18650 by about a millimeter. Grab my snips. Pull the battery out. Oh, never mind. The whole thing came out at once. Alright, so I don't think we need this plastic case anymore. I'm going to hang on to it though, because if the circuit's not bad, I may swap the battery out and make an even better one. Okay, so since they were nice enough to give us these wires, I'm going to go ahead and desolder them. That'll make it easier for me to test the charging on the battery. We'll leave it intact the way that it is. Actually, I'm going to do that. That. Now with these, we want to be careful. This is a LiPo battery. If we end up shorting out the LiPo battery, it will explode. It will vent and it will start on fire, and it's lithium, and when lithium burns, it produces oxygen, which means it's a very hard fire to put out. So if you're ever ripping something like this apart, be very careful with these. So as I said, I wanted to know if this is taking some kind of trickle current. So I'm going to strip back some of the insulation here. Okay, we're going to hook into my bench power supply, just so you can see what I'm doing. I have my power supply set to 4.2 volts at a maximum of 3 amps. If we need to go higher in amps, we can, but I'm going to start off conservative. And we're going to hook up the positive to this thing, and the negative to this thing. Okay, so as you can see, it's hooked up, and we'll start simulating a battery. Nothing seems to be going on. Alright, well that's a good sign. So we have nothing drawing current from the pack yet, or the makeshift pack, and it doesn't draw current at all. So I don't know why they put that standby of 180 hours in there. Lithium-ion battery should hold its charge longer than that, just on its own, by its own nature. But yeah, it doesn't draw current when it's not doing anything. So now, let's make it do something. I have one of these cheap cameras from the last video. We might as well use it. Alright, so I'm going to plug it into here. I'm going to pull its battery out. I forgot how hard it is to get the batteries out of these things. Ugh. Crappy camera. Like, everything about it is just complete garbage. Okay, I'm going to turn the power supply off just for a moment while I plug this in so I don't accidentally short it out. So now it's got something to do. And now we're drawing current. And the camera has turned on. Alright, so we know that our connection was fine before. And if I pull out the thing here, we drop to no current being used. Okay. So that tells me everything I need to know about that. I don't know why that light is suddenly on. Whereas if I unhook that and I plug it back in, I guess it stays on after a draw. Alright, well, let's turn the power supply off. Unhook this. Unhook this. Alright, so let's take a look and see what IC is being used here. Okay, I'm just going to take a moment to power up VLC. Alright, so here we go. Unlike that cheap camera, I was actually able to find information on this. P-channel MOSFET. Apparently this particular IC is used for a lot of power banks. Let's take a look at some of the application schematics here. You can tell that it's definitely the design that is used in this particular device. I would like to find its data sheet. Alright, and if we look at the actual unit here, it looks like they just applied almost this identical circuit. Wow, alright. This appears to be the circuit that is being used in our device, down to the inductor and the values of the capacitors and resistors. This battery is just our battery charge, the out to the lithium ion battery. And the capacitors, USB in. Obviously, everything that we don't need the data lines for USB, so we don't connect them at all. Alright, and then we just short data in and data out here so that anything that does want to see the data in and data out short in order to charge will charge. It looks like a very, very simplistic circuit. Let's see if we can find a data sheet on this. I want to know what protection pieces are in here for this. I don't know if AliExpress will have a data sheet, but apparently 50 of them are $7. So $4 for this at Poundland is probably a little much. Or at the dollar store. Sorry. I don't know why this is calling it a P-channel enhancement mode MOSFET. Oh, because it's the wrong part. Just happens to be named the same thing. I hate it when they do that. But it's a good reminder to always check the picture of the part when you're looking up data sheets. It's almost like they don't want me to find the data sheet. 3401A. Okay, so apparently I don't get to find a data sheet on this IC. But we do have working schematics. And it does look like the Chinese manufacturer of this power bank just blatantly ripped off the schematic, probably directly from the data sheet of the IC. The inductor values, the resistor values, everything's the same as what you see in this diagram here. So the next thing I wanted to look at is the capacity of the battery what they say it is. Now, first off, I want to see if the battery itself is currently charged. So I'm going to grab my multimeter. I'm going to switch it to volts DC. Now, a fully charged single cell lithium ion or lithium polymer battery should be 4.2 volts. Let's see what this one is. 2.7, which means it's already dangerously low and to the point where it might not be easily salvageable. Alright, let's see if we can even charge this thing at this point. Generally don't like lithium ion or lithium polymer cells to get below 3 volts per cell. So I'm going to grab this guy right here, this guy right here. Now, as I said, with lithium-based batteries, please, for the love of God, be careful. Right? Shorting is extremely dangerous. There's been plenty of houses that have burned down and people who have burned legs and all kinds of other stuff going on. So there's been plenty of people who've done horrible amounts of damage to themselves and their houses with lithium-ion and lithium polymer batteries. So if you're going to do something like this, be careful. Everybody here heard me tell you to be careful. Burn your house down, not my responsibility. So with that in mind, this charger uses banana plugs, which are going to be inconvenient for me. And what I'm doing is I'm covering the live end of my banana plugs because we have this section back here where I can use to grab contact with the alligator clips I'm going to be using. Again, this might seem like a crazy level of protection, but people have literally burned their house down doing stuff like this. So, I'm better off safe than sorry. And since part of this experiment is going to take hours and it's going to be running basically unsupervised, yeah, no chances, guys. Don't take chances. So, we're going to take one of our alligator clips, insert it into there, making sure we make contact with the metal on the inside of that part. And then we are going to go ahead and grab our other alligator clip, in contact with the metal on the inside of here. Okay. Now, I really want to find some tape, because there is still those two big exposed pieces there that I don't like. I know I'm being crazy with safety, but safety is always important, guys. Let's be crazy with safety. Okay, so we've got some tape. I'm going to tape up the positive one, like so. And then we'll add the negative one so things aren't flopping around. Ground being exposed is not all that bad necessarily, but okay, so we got a good connection there. So now I'm going to go ahead and slide these boots as forward as I can. And we're going to clip onto that lead, and we're going to clip onto that lead. And we're going to go ahead and bring the charger over. See if you can see what I'm doing here. So since this is already at what I would consider a fully discharged part, I'm going to say charge this battery. Just checking the battery to see if it can charge it. And we're charging. It says it's at 2.7 volts. It's charging at 0.4 amp right now. I don't know if you can see that anymore. And this is going to take a bit of time. So, we'll be back. Alright, so here we are a day later. I've run about a half dozen charge and discharge cycles on the battery that was inside of the battery pack. Now the package, if you remember, let's pick it up off the ground. It got a little smashed. Says on the side, hopefully it'll focus on this. $1,800 milliamp hour. That is a lie. Through my charge cycles and discharge cycles, bringing the battery up to its full charge at 4.2 volts, down to its minimum safe voltage of 3 volts. I'm getting a charge and discharge of about 1.2 amps, so 1200 milliamp. Now keep in mind, this is at the 3 to 4.2 volt range. I'm just going to quickly do some math here. Assuming a lossless boost circuit to boost the battery voltage up to 5.2, which is not possible. But let's assume a lossless circuit. You're looking at about 900 milliamps to 1 amp of power in these batteries. So 1800 milliamps is a huge lie. I was a little disappointed that I wasn't able to find the datasheet for the IC that drives this. I was also not surprised though that the schematic used for this is identical to the ones that you can find on Google quite easily. So the charge circuit is cool. The battery sucks. I don't know if there's a protection thing in here. Let me turn on the bench cam. Let's just tear down this battery. Again, if you're going to tear down a lithium-ion battery, be safe, please. This is dangerous. If you don't know what you're doing, you can hurt yourself badly. So what we're going to do now is I'm just going to unhook these leads. And pull this back just a lot so that it's not in my way. And there's less chance of me shorting the battery up. We'll take that right off. I'll take this insulator cap off. I'll take this cap off. Now there is no battery protection circuit on this. So, what this leads me to believe is quite simple. The battery's crap. We can use the circuit that we've been looking at for other projects. Make a much bigger battery pack by putting multiple of these 18650 cells in series. 3D print enclosure and come up with something cool. So not a waste of $4, and if you're kind of in a pinch and you just need something that's just going to give your phone maybe half of a charge, this might be fine for you. I don't know if it's worth $4, but I enjoyed looking at the inside. I hope you learned something today, and I will see you next time.